Let's now run a two-proportion hypothesis test. And for that, we are going to need the pooled estimate. And to get that, we are required to have n1, n2, and x1, x2. Those are the number of success and sample sizes as n1, n2. So let's go down here and let me actually insert a row just to separate things a little bit. I'm going to select this and use boldface. Okay. So pooled proportion. And that's gonna happen in this cell B29. Alright, the formula is x1 plus x2, open parenthesis. In the table, x1, we call that the ones who said no. You could just click on that. Plus x2, close parenthesis, divided by open parenthesis again, n1, 510, plus n2, close and enter. That is the combined proportion or the pooled proportion. Next, you have to find the standard error for hypothesis test. That standard error takes in the estimate for the pooled proportion that we just found. So it's not like the standard error that we found for the confidence interval above, this number 0.023. You're going to have to use p hat or the pooled estimate. Using pooled proportion. Once again, we'll use square root function equal to sqrt open. Use the pooled proportion by just clicking on it times 1 minus p hat, click, close, divided by n1. I called n1 510. Click on 510 plus p hat again is 0.408 times 1 minus p hat, click on 0.408 divided by n2, and n2 is 2943. Close and hit enter. That is the standard error using the pooled proportion. And as you see, that standard error is almost equal to the standard error that you found using the two separate sample proportions. So 0.2357, 0.02388, almost close. Having found this standard error, we can go ahead and find the test statistic, which is a z-score. And that z-score standardizes this observation of 0.077. And that will determine if this difference between the two observations is significant or not. We're going to take that, standardize it by dividing it by the standard error that we just found. So let's call this the test statistic. or a z-score for the observed difference. Again, equal, click on the observed difference and divide by the standard error, hit enter. We get a z-score of 3.28, and you can already see that what we observed is really significant. That z-score is way above 2 standard deviations, which makes this outcome unlikely. And that leads into the rejection of HO, that the two proportions are equal. Keep in mind that I have been treating this problem as a two-tailed test. The confidence interval for comparing the two proportions, if it's a 95% confidence interval, then you can use alpha as 0.05. And the p-value will correspond to the area less than negative 3.27 and more than 3.27. You can just find one of the areas and multiply it by 2. So let's say p-value. Now, Excel can find the exact p-value for you. You can also use your t or use your z table. But I'll just show you how to find that area. You type in equal. The syntax to find the area under the normal curve is norm dist. The syntax is actually compatible with Excel older than 2007 or earlier Excel, like 2003 or 2000. Open parenthesis. Okay, now if you notice here, this function is asking you for x, for the mean, for the standard deviation, and then here they ask if you want a cumulative area, which that's exactly what you want. So type in, for x, you can type in negative. Keep in mind that every time we find the area given to us is the area to the left of a z-score, not to the right. That's why I'm using the negative to find the area to the left of negative 3.27. Type in negative and then hit on the z-score, then comma. The mean for the z distribution is 0, comma. The standard deviation for the z distribution is 1. So for all of you, you're going to type in 0 and 1. And you're going to have to tell Excel that you want the cumulative area, which is the area to the left of 3.27. All you have to do is type in true. Close parenthesis, hit enter. That is the area to the left of negative 3.27, but you need to multiply that by 2. So I'm just going to double click on this cell and edit it by typing in 2 times and then hit enter. That is a p-value, and the p-value is pretty small. It is less than alpha of 0.05 if you assume your alpha to be 0.05. Well, what does this mean? I am going to have to leave the interpretation of p-value to you, and you have to do the interpretation in the context of your problem. But for this problem, assuming that the two proportions are equal, the probability of uh, observing a difference of less than negative 0.077 or a difference of more than 0.077 is about 0.1%, which makes this observation unlikely if HO was true. That means you're going to have to reject HO.